Hi guys, welcome back. We're going to continue talking about graphing parabolas. So we talked about graphing parabolas in 9.1 where we made a table. But the thing is, when you have a table, sometimes that doesn't give you the full scope of what the quadratic looks like. We want to be able to see the full U shape. So in order to do that, we want to find the axis of symmetry and the vertex, especially because sometimes our axis of symmetry or vertex might be a decimal or a fraction, okay? So that might not be seen very well in just a table. So we're going to practice finding our axis of symmetry again. Again, that means I'm going to find my A, B, and C. So A in this case would be 1, B -4, C -5. Again, we don't really need the C in this case, but it's a good habit to get into to identify them. So we have x equals -b, which would be -4, over 2 times A, which is 1. So this would be +4 over 2. 4 divided by 2 is 2. So my x value is 2. So I would go over to my graph here and draw my axis of symmetry. And notice it's a dotted line, okay, not a solid line. It's not part of my graph, it just helps me to draw my graph. Next I'm going to find my vertex. And I'm going to do that by plugging in x equals 2 into my formula, into my equation. So I have 2 squared minus 4 times 2 minus 5. So I'm going to get 4 minus 8 minus 5. So that would be -4 minus 5, which would give me -9. Now another thing to know, I know that my leading coefficient here is 1, so it's positive, so I'm going up. So I know my parabola is going to look something like this. Okay, so I have the vertex being 2, -9. Now on my graph over here, I'm going to count by 2's. So I have -2, -4, -6, -8, -10. So my vertex is 2, -9. So I've now plotted my vertex. Now the next point is we need to find at least 2 more points. So I'm going to start with one of them. And when I want to pick an x value, I want to look at my axis of symmetry and I want to go 1 or 2 away in either direction. Okay, I don't want to go too far from the axis of symmetry. If 0 is available, like here, 0 is not on the axis of symmetry, choose 0. But in this case I could choose 0, 1, 3, or 4, and that would still get me a helpful answer. Okay, but 0 is always a nice number because things cancel out. So if I plug 0 into my equation, so I have x squared minus 4x minus 5, I'm going to have 0 squared minus 4 times 0 minus 5. 0 minus 0 minus 5 is -5. So I have the point 0, -5, because I plugged in 0 for x and got -5 out for y, because this is in fact equal to y. So I'm going to plot the point 0, -5, and let's erase these pink marks for me. Okay, so I have 0, -5. Now what happens is to find my third point, I don't really need to do any more math work, but I know my axis of symmetry is a mirror. So since this point is 2 away from the axis of symmetry, my point on the other side will also be 2 away, or 2 units, okay? Now I can get rid of this pink here in the middle, I don't need to show that. But now I have 3 points, which is the minimum you need in order to graph a parabola. I could plug 1 into the formula and see what I get, but I don't have to. And I know it's a nice curvy line, and I know it opened upward already from my earlier statement. Okay, and now I have graphed a parabola. So the nice thing is you only have to find 2 points technically, and the third is easy to get. But you know exactly where it's going to be on the graph. You don't have to try and guess and check with points in a parabola graph. Or a table, I'm sorry. Hopefully that makes sense. If it doesn't, let me know. So the next one, we're going to kind of look at a real world problem. Why do we use quadratics? So the height of a football is kicked and can be modeled by the function f of x equals -16x squared plus 64x, where x is the time in seconds after it is kicked, the football's maximum height, and the time it takes to reach the ground. Sorry, it's being fussy here. To reach that height, I'm sorry, and find how long the football is in the air. So I kind of wrote down the equation because it put it on 2 separate pages. And what those 3 questions are. So we want the maximum height, we want the time to get that max height, and when does it reach the ground? So if we think about a football flying in the air, so if we have a football on the ground and we kick it, it's going to go up and then make a downward to go back to the ground because of gravity, right? So quadratics play a big role in what happens when something goes up and then down, right? So you're kicking a soccer ball, a football, whatever, okay? So in order to do this, we want to graph this, okay? So we're going to find the axis of symmetry. So in the axis of symmetry, again, I'm going to say A is negative 16 and B is 64. We're going to have x equals negative b over 2 times a, which becomes negative 64 over negative 32, which becomes a positive 2. So I'm going to graph at 2 here, which I'm counting by ones here. So I'm going to have my dotted line on my axis of symmetry. Sorry, that one got a little bit away from me. Oops. Okay, so a dotted line on my axis of symmetry. Now I'm going to find my vertex. Now remember, I find the vertex by plugging x in. We'll do that in red. So we're going to have negative 16 times 2 squared plus 64 times 2. So it's going to give me negative 16 times 4 plus 128. And that would be negative 64 plus 128, which is conveniently going to be at 64. And again, I know this is going to open downwards, right? So I know it's going to be a parabola that looks like this. Okay? But the point 264 is right here. Now I counted by 16s just to make it fit on my graph, but you can make a bigger graph and count it later. Now again, just like before, I'm going to pick a point that's close to my axis of symmetry. Now I'm going to choose 0 in this case. Like I said before, 0 is just pretty, right? So if you plug in 0, so we'd have negative 16 times 0 squared plus 64 times 0. Conveniently, when you multiply things by 0, you get 0, and add zeros together, you get another 0. So we have the point 0, 0. Okay, I'm going to erase these other red points here. So I have the point 0, 0, and I'm going to mirror that. Since that's 2 away from my axis, I'm going to go 2 away from my axis the other direction. Okay. And now I have this nice cool parabola. Now, the thing is, sorry, I have my eraser on. We don't want to show this extending further this way because x is time, right? So I can't have, negative height, right? Since y is height. Okay, and I can't have negative time, so I can't have x being negative over here. So we're not actually going to extend our lines. So you kind of have to think about the real world situation and does it warrant me continuing the lines forever? So let's think here if we can answer some of these questions. What is the max height of the football? Well, we know the maximum point here is right here. Now that point is 264. Do I want the x value or the y value? Well, the y value stands for height, so I want the 64. So the football reaches a height of 64 feet. Okay? And how long did it take to get to that max height? Well, the point is 264, so it took 2 seconds. Since it did say x was time in seconds. Okay? Then to reach the ground. Now that is when the height is 0, right, is the ground. So if I look here, y is 0 in 2 spots, here and here, just like we found our zeros before in our problem. Well, which 0 is it? Well, they want to know how long does it take it to reach the ground after it's already been hit, right? So this first is the time 0, 0. So that's at, before we even kicked the ball, it obviously was at the ground 0. But here we have the point 4, 0. So after 4 seconds, the ball will hit the ground again. Okay. So by taking this function, we were able to graph it and figure out, okay, what was the height of the football at the end? How long did it take to get to that max height? And how long did it take it to reach the ground? And just remember the big deal, the ground is when y is 0. Okay. Hopefully this helps.